So starting in section 8.2 on page 240, we have a description of what are called layer silicate clays. And this might look kind of complex, but I think if you just kind of take it in, you'll be fine. And so I want to explain some of the terminology, and we're going to take a look at some of these structures. Silicate just means it has silicon, and so in this example, you can see that here is silicon right here, and oxygen. Those are the two kind of building blocks for clays. You would be familiar with silicon dioxide, which is sand. So sand is basically silicon and oxygen, and clays are as well. Except for clays, they're actually formed in sheets. So you can see over here on the right hand side of this graph that we have sheets that make up clays, and we saw in the last figure that clays can look much like the pages of a book. So sheets stacked together. And that's exactly what we're going to look at. So we're going to just zoom in on what these look like at a really molecular level. So a framework, basic framework level. The top of this graph here, so you can see that we're looking at a clay. Here's our interlayer spaces. Here's our layer. Here's another interlayer space here, and another layer. And so we're zooming in on these clay structures that we saw in the last figure. Basically, clays are built of two kinds of building blocks. The first one is called the tetrahedron. Tetra is 4. We'll see octa later, 8. So what we're thinking about here is the sides of this basic unit. So here is our tetrahedron, and this tetrahedron has 4 sides, so it looks like basically a pyramid. So it has 3 sides and then a bottom, so 4-sided. And you can see that this unit is making up a whole sheet here. So we've just pulled this thing out here to take a look at it. If we put it back in there, we'll see that there's a whole, what we call a plane of these. Okay, so a whole sheet of these. And usually these don't occur just alone. When we're thinking about clays, they don't occur alone. They also occur with another unit called an octahedron, an 8-sided polygon. Okay, if we're thinking about polygons. So this sheet on the top has 2 tetrahedral sheets, right? Remember we said this is a tetrahedron right here, and if we put it into sheets with a bunch of other tetrahedrons, we have a tetrahedral sheet. That's interesting. Okay, so most often these are made up of silicon. So you can see again, here's our silicon in the middle, and oxygen on the outside. 4 oxygens, 1 silicon and 4 oxygens for 1 tetrahedral unit. When we start to put these together and associate them with other tetrahedral units, we'll get a tetrahedral sheet, as we see. And sometimes, not sometimes, and they also share oxygens. So it's okay in these structures for them to share oxygen molecules. So you can see the attachment together of some of these sheets because they are sharing the oxygen molecule. So that's the tetrahedral unit and the tetrahedral layer, or the tetrahedral sheet. Now you're going to ask, why in the world are we learning this? Why is this important? And we'll go through that in a little while when we talk about substitutions. So that's the tetrahedral. This is the octahedral, okay, the octahedral, the 8-sided unit. And you can see that there's a sheet of these, okay, in the middle. Typically, we only have one sheet of these, either sandwiched between two tetrahedral sheets or just in association with another tetrahedral sheet. In the octahedral configuration, you see here we have either aluminum or magnesium, and then we have a hydroxide. Okay, this is an oxygen with an associated hydrogen, or sometimes just an oxygen. So, so this is how we make that up. So one of these aluminums or magnesiums, 6 of these hydroxides, or just oxygens. And you can see these make up, when they associate together, they make up a sheet just like we've seen. And so again, think about that clay that we saw in the picture. We're zooming in on that clay and we're seeing that it's composed of several different sheets, and those sheets are tetrahedral and octahedral sheets. We're going to talk about isomorphic substitution, or isomorphous substitution as your book calls it. You'll see that. You need to read that section on page 241, and we'll talk about it in the next video.